On August 12, 2026, millions of people looked up and watched daylight disappear. Across Spain, the moon crossed directly in front of the sun, turning a familiar afternoon sky into one of nature's most precise and unsettling spectacles, a total solar eclipse. But an eclipse is not simply a beautiful shadow. It is a live demonstration of scale, motion, and perspective. In a few minutes, the moon reveals how three worlds can line up across space with astonishing accuracy, and how fragile our experience of daylight really is. The story begins nearly 400,000 kilometers away, where the moon is moving around Earth at more than 3,000 kilometers per hour. At the same time, Earth is racing around the sun at roughly 107,000 kilometers per hour. Nothing in the sky is standing still. Yet from the ground, the geometry can look almost frozen. The sun is about 400 times wider than the moon, but it is also about 400 times farther away. That coincidence makes the two disks appear nearly the same size in our sky. It is why the moon can cover the bright surface of the sun so completely while leaving the outer atmosphere visible. On most days, we never notice this alignment. The sun is too bright to look at directly, and the moon is usually somewhere else in its orbit. During a total eclipse, however, the alignment becomes visible as a moving boundary between light and darkness. The darkest part of the moon's shadow is called the umbra. It is not a giant cone spreading across the whole planet. It is a narrow corridor, usually only a few dozen to a little over 100 kilometers wide, sweeping across Earth's curved surface. That narrowness is what makes totality so special. A partial eclipse may be seen across a wide region, but totality is available only inside the moving umbra. Two observers separated by a short drive can have completely different experiences. One sees the sun become a crescent, while the other sees the solar disk vanish. As the moon's shadow approaches, the environment changes before totality arrives. Shadows cast through leaves can become tiny crescents. The air may feel cooler. Colors can appear strangely muted, and the horizon may glow with a ring of sunset in every direction. Animals sometimes react as well. Birds may settle, insects can begin their evening rhythms, and nocturnal creatures may become active for a brief interval. These reactions are not mystical. They are biological responses to a sudden change in light and temperature. Then the final sliver of sunlight breaks into beads along the edge of the moon. This is Baily's beads, created by sunlight shining through valleys and gaps on the lunar surface. The last bright flash is often called the diamond ring, when one brilliant point of sunlight remains beside the dark lunar disk. And then, for a short time, the sun's photosphere is gone. The black circle is not the moon itself in ordinary visual terms. It is a silhouette, hiding the visible surface of the sun. Around it appears the corona, a vast atmosphere of plasma shaped by magnetic fields. The corona is millions of degrees hot, yet it is so thin that it normally contributes only a faint glow compared with the solar surface. Its structure can look like pale, silver-white streamers extending into space. Near solar maximum, the corona may appear more complex, with loops and irregular rays pointing in different directions. What we see is not smoke or flame. It is the architecture of a star's magnetic field, made visible because the moon has blocked the overwhelming brightness beneath it. The reddish edge around the moon is another layer, the chromosphere. Tiny prominences may rise from the sun's surface, shaped by magnetic forces and filled with hot hydrogen plasma. They can look like red sparks around the black disk, but they may be larger than Earth. An eclipse also exposes something about scientific measurement. The shape and brightness of the corona are not just visual details. They help astronomers study solar wind, magnetic fields, and the eruptions that can send clouds of charged particles toward Earth. Those eruptions matter because our planet is connected to the sun by more than gravity. The solar wind constantly flows through the solar system. When it becomes disturbed, it can interact with Earth's magnetic field, producing auroras and, in stronger events, disrupting satellites, radio communication, navigation systems, and electrical infrastructure. So the eclipse is a quiet opportunity to study a star that is normally too bright to examine in this way. Ground-based telescopes, aircraft, balloons, and spacecraft can all observe different parts of the event. Some instruments measure the atmosphere. Others monitor the sudden change in light passing through Earth's atmosphere. The 2026 eclipse was especially remarkable because totality crossed parts of Spain, where the event unfolded during the late summer afternoon. Observers gathered in cities, villages, coastlines, and open countryside, searching for clear skies and a good view of the moon's shadow. For each location, the timing was slightly different. The shadow moved from west to east, and totality lasted only minutes. The entire eclipse, including the partial phases, lasted much longer, but the central moment remained brief, an astronomical event compressed into a human heartbeat. That brevity is part of the emotional power. We can predict the eclipse centuries in advance, calculate its path to extraordinary precision, and still feel surprise when the sky actually changes. Prediction removes uncertainty, but it does not remove wonder. There is also a deeper reason eclipses feel important. Human beings evolved under a sky where the sun was the dominant object and darkness arrived gradually each evening. Totality interrupts that rhythm. It creates a midday night that is not a normal night, because the horizon remains bright and the stars appear in an unusual arrangement. The experience reminds us that daylight is not a permanent property of Earth. It is the result of geometry, a planet rotating into sunlight, an atmosphere scattering blue light, and a star illuminating one side of a small world. The moon's shadow makes that geometry visible. It also gives us a changing view of time. The eclipse is predictable because orbital motion is regular. But it is not repetitive in exactly the same place. Earth turns, the moon's orbit is tilted, and the shadow traces a different path across the planet each time. Every total eclipse belongs to a family of related events, yet each one is geographically unique. Over long periods, the moon is slowly moving away from Earth, by roughly a few centimeters each year. In the distant future, its apparent disk will no longer be large enough to cover the entire sun. Total solar eclipses will end, replaced by annular eclipses in which a bright ring of sunlight remains visible. That fact gives totality a temporary quality on a planetary timescale. We are living during an era when the moon and sun appear almost perfectly matched. The coincidence will not last forever. For anyone observing an eclipse, safety remains essential. Looking at the uneclipsed sun without certified solar viewers can cause permanent eye injury, even when the sunlight feels weaker. Regular sunglasses are not enough, and cameras or binoculars require proper solar filters designed for the instrument. Only during the brief phase of totality, when the sun's bright surface is completely covered, can the sky be viewed without eclipse glasses. The instant sunlight returns, protection is needed again. This balance between awe and caution is appropriate. The sun is beautiful because it is powerful, and dangerous for the same reason. An eclipse does not weaken the sun. It simply places the moon between us and the source of its light. When the moon finally moves away, the diamond ring returns. The corona disappears. The sky brightens rapidly, temperatures recover, and ordinary shadows return to the ground. In a matter of minutes, the world looks normal again. But the observer is left with a different understanding of the sky. The sun is no longer just a bright circle. The moon is no longer just a pale companion at night. Earth is no longer just the place from which we watch. Together, the three bodies formed a moving instrument, one that revealed a star's atmosphere, measured the precision of celestial mechanics, and turned an invisible orbital path into an experience shared by millions. The shadow has passed, but the lesson remains. Space is not distant and abstract. It is active above us, governed by motion, magnetic fields, and immense scales that briefly become visible from a patch of ground. And when the next strange darkness crosses the daytime sky, the wonder will begin again, not because the eclipse is unpredictable, but because knowing exactly when it will happen makes the arrival of totality even more extraordinary.